Hello, welcome. Let's try to solve another Leetcode problem, 653. So for this problem, we are going to calculate the two-sum for. So the input is a binary search tree. So for example, this is 5 at the left side. The node 3 is smaller than 5. At the right side, the node 6 is bigger than 5. So we are giving this value k. We just need to find two nodes. The value of them, the sum of the value of the two nodes are gonna be this value k. So for example, 3 and 6, 3 plus 6 are gonna be 9. So this is true. And for this example, it is 28, and we cannot find two nodes. The sum of the value of two nodes is gonna be 28. We cannot find it, so it's gonna be a false. Yeah, so the idea is just the two-sum. We're gonna prepare a set. So while we are traversing this tree, so for example, this value 5. So for the first value, so this value is 5. So what's gonna be the k minus 5? It's gonna be 4. So 4 is not inside of the set, so it is okay. Now we're gonna put 3 inside it. Yeah. So 6 is not inside of the set, so we're gonna put 3 inside of the set. So inside of the set, we're gonna have the values like 5 and 3. Now, while we are traversing this node 6, we're gonna check the result. So the result is gonna be k minus 6 is gonna be 3. 3 is inside of the set, so it's gonna be true. So this is the idea how we're gonna solve it. Yeah. So let me just define a DFS. So this is going to be the node. So if node, the result is going to be the target. It's going to be k minus the node dot value, because we are checking this node. If it is exist, so we're going to have this result. If the result is inside the set, this means it's going to be a true. Otherwise, we're going to put it inside the set. Yeah. So we're going to put a node dot value inside the set. So finally, we're gonna return the left and the right side. Yeah. And from here, we're gonna return a false if we didn't find it. So finally, we're gonna return DFS with the root. Yeah. Now let me just run it to check if it works. As you can see, it works. Yeah, so the idea is just the binary search tree. Actually, it is a tree traversal. For the first value, for example, this is 5. We're going to put the 5 inside the set until we find another value 4, because 9 minus 4 it is 5. 5 it is inside the set, so it's going to be true. Yeah, so the idea is just the two-sum. So the time complexity is going to be O(n), and the space complexity is going to be O(n) as well. So n is going to be the number of the nodes, so it is 10 to the power 4. That is why it is fast. Yeah, I think that's all about